All right, let's continue on the notes. I just got interrupted earlier. So now I want to start graphing the secant graph. And we know that secant and cosine are related on the unit circle. Cosine is the x coordinate around the unit circle, and cosecant is the reciprocal of that x coordinate. So let's just remind ourselves what the cosine graph looks like. Its period is 2 pi, which we divvy up into 4 parts. The cosine graph starts at its amplitude, which is 1, and then it hits 0 at pi over 2. Cosine of pi is -1, back to 0, back to 1. So here's one period of the cosine curve. And we can continue that to the negative side. So at -2 pi, cosine starts at 1, and then it hits 0, and then -1, 0. Here's our second period. And if we want to look at domain and range, the domain of the cosine function is just like that of the sine function. It's all real numbers. There are no vertical asymptotes, jumps, holes, or discontinuities for the cosine graph. And the range stays between -1 and 1. To generate the secant graph, let's write down the coordinates for cosine, and then it'll be easier to write down the reciprocal of those values to get our points to plot for secant. So the cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is -1, cosine of 3 pi over 2 is 0, and cosine of 2 pi is +1. So for the secant graph, the reciprocal of 1 is 1. The reciprocal of 0 is undefined. The reciprocal of -1 is -1. Reciprocal of 0 is undefined. And reciprocal of 1 is 1. We're going to do the same thing we did with the cosecant graph. So anywhere we have a point, we'll plot it. So 0, 1, we can plot that point. Anywhere we have an undefined, let's draw in a vertical asymptote. So there's one at pi over 2. And then at pi, we plot a point at -1. At 3 pi over 2, there's a vertical asymptote. At 2 pi, we plot 1. So right now, one period, because remember this was one period of the cosine curve, one period of the secant curve looks like this. It's kind of strange. It has one full branch in the middle here, and then sort of like a half branch on either side. So that's one period of the secant curve. And we can continue this on to the negative side. So remember, this is periodic. So I can see that the vertical asymptotes are happening at the pi over 2. So I'm going to draw those in. There's one at -pi over 2, and there's one at 3 pi over 2. And then even though these look like half curves, they do continue on. So this secant curve comes up this way. And then at -pi, the secant curve has a point at -1, goes down. And then it ends at 2 pi, hits 1, and I'll show this part of it. This would be 2 full periods, but these do go on forever. So know that like this curve continues, and so does this. What about the domain and range? So domain is not all real numbers. The domain, I'm not sure why I have asymptote equation right there as well, but the domain is the asymptote equation, right? So it's all real numbers. X is not equal to what? So now it's every multiple of, well, let's see. Is it every multiple of pi over 2? I don't think so, because it's not like 1 pi over 2, 2 pi over 2, 3 pi over 2. It's every odd. The next one will be at 5 pi over 2, 7 pi over 2. So how about this? Let's designate pi over 2 as the first asymptote. To get to the next asymptote, there's a distance of pi between these, right? 3 pi over 2 minus pi over 2 is pi. So I could say add pi to get to the next one. Or I could have said subtract pi to get to this one. Or I could have said subtract 2 pi to get to the -3 pi over 2. So it looks like we're adding multiples of pi times k, as long as k is an integer. So that ought to hop us from one asymptote to the other. So that's our domain. And then the range is the same range as cosecant. The bottom branches range from -infinity up to -1. And the top branches begin at 1, go up to infinity. All right, so we're going to use the same rules that we use to graph cosecant to graph secant. So if I see that this says graph y equals 2 times the secant of 2x, I'm really going to think of y equals 2 times the cosine of 2x. So let's get that graph first. Now, secant does not have an amplitude, but I can figure out the period in the asymptote equations. So the period is 2 pi divided by 2. So the period is pi. So let's divvy up pi into 4 equal parts. And let's do that little ghost curve like we did before. So the cosine curve has an amplitude of 2. And then it hits 0 at pi over 2, negative 2. 0, 2. So here's the little cosine curve. Let's continue that cosine curve on. This is every 1 unit. So 0, negative 2, 0, 2. Let's do it on the negative side. So 0, negative 2, 0, 2, 0, negative 2, 0, 2. All right, so here's my cosine curve. I'm not going to sketch in the whole thing. Just like we did with cosecant, we need to plot vertical asymptotes anywhere this cosine graph is equal to 0, because the reciprocal of cosine when it's equal to 0 will be undefined. So I'm sketching these in. All right, and then just like with cosecant, these local max and min points are where you plot your first point, and then you sketch in the branches of the secant curve just to fit in between the asymptotes. That's about as accurate as we're going to get. For our AP exam, we're not going to be sketching a lot of these graphs by hand, but we have to be really familiar with how the graphs are generated so that we can match graphs to their proper equations and answer questions about them. So the skill is important to have, even if you might not be graphing by hand all over your AP exam. What about the asymptote equation? You can look at this and try to get the pattern. I see that it's at pi over 4, 3 pi over 4, 5 pi over 4. Or we could solve an equation. The original asymptote equation, x is not equal to pi over 2 plus pi k. We have a 2x, so we set 2x not equal to pi over 2 plus pi k. Solve for x. When you divide everything by 2, you divide every term by 2. So x is not equal to pi over 4 plus pi over 2 times k. K is an integer. We can use kes. K is an element of the integer number set if we need to. And then you can double check to see if this is right. The distance between any two asymptotes is pi over 2. So pi over 4 plus pi over 2 or plus 2 pi over 2 or whatever, that works out. Let's do one more graph. So we've got y equals the secant of pi x over 2. So let's think of this as cosine to begin with. There is no amplitude for the secant graph because amplitude means the distance between the local max or min and the x-axis. Or not the local, I'm sorry, the global max or min, and secant and cosecant, they don't have global maxes or global mins. So the period here is different. It's 2 pi divided by pi over 2. So the pi's are going to cancel out. You're going to get a period of 4 radians. And so the nice thing about having this blank canvas is I can still just say, okay, here's 4 radians. Here's 2 radians. Remember, 4 radians is not the same as 4 pi. Like 3.14 is pi, so maybe this is where pi falls. But we don't have to worry about the scale because we're kind of making our own scale. So you can make life easy on yourself and not worry about the pi's. What about the asymptote equations? Maybe I want to find these before I get started. So take the parentheses, set it equal to, what was it, pi plus k, it was pi over 2 plus k pi, right? Multiply everything by 2 over pi to solve for x. Okay, so that means that x is going to be not equal to 1 plus 2k. K is an integer. Let's see if that checks out when we do this. All right, so our cosine graph, we've already got the period divvied up. The cosine graph would start at 1, hit 0, -1, 0, 1. Repeat that on the negative side as well. Plot in your vertical asymptotes where the cosine graph is equal to 0, because that's where cosecant will be undefined, or that's where secant, will be undefined. Plot your points at each value where cosine hits 1 or -1, and draw in the branches. I'm just always going to ask that you, whatever grid I give you, that you fill the grid for a test or a quiz. So it's not necessarily how many periods do I want you to graph. It's more I just want you to fill the grid. And I might ask, how many periods is this? So remember, this is 1 period, 2 periods, or another way to figure that out is our grid has a span of 8 and the period is 4, so we get 2 periods graphed in here. All right, that's it for this set of notes. We will practice today with a worksheet.